All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part 4 of our lecture on the Internet Protocol, and we will jump to the point from where we left off, which is going to be an IP addressing example. So what we were looking at so far is called the classful IP addressing, and this is going to be a classic example how we can look into an IP address and calculate all the related information. So first of all, we have a host IP address 137.143.64.130, right? So we will first convert it into the equivalent binary. So 137 would convert to 1000, 1001. Then 143 would be converted to this, and so on and so forth, right? So we are done with our preset. We are given the host IP address. We convert each of the decimal values to the equivalent binary. So now, when we look at the binary, we see that the first octet starts with 10. So given that the first octet starts with 10, we know that this is going to be a class B address. So therefore, for class B, the first 16 bits is a part of the network ID, and the remaining 16 bits belong to the host ID. So taking it from here, we will first calculate the network address, where we just set all host bits to zeros, and we calculate the equivalent decimal values, where we already know 137.143 to be the first part and all zeros to be zeros. So we now know the network address. The broadcast address, for the same segment of the host bits, we just set all the bits to ones. So 8 binary ones would mean it is an equivalent of decimal 255. So the broadcast address is 137.143.255.255. And finally, the network mask is where we set all the bits in the network ID part to ones and all the bits in the host ID part to 0. So we have 255, 255, 0.0. All right. So far what we looked at were IP addresses which belong to certain classes, and we can identify the class by looking at the first few bits of the first octet, right? So for class A, it's a 0 in the first bit. For class B, it's 10 in the first 2 bits, and so on and so forth. However, this is an earlier version of IP address management where we used classful IP addressing. The newer version of IP address management uses classless IP addressing. It is also known as what we call CIDR, which is short for classless interdomain routing, right? And what happens is that we have the network ID and the host ID lengths to be variable. So how do we know what is the length of the network ID? Well, the IP addresses now have a slash at the end of the IP address followed by a number. So therefore, in an example right here, 137.143.64.130 is our IP address, followed by a CIDR notation /16, which means that this is a /16 network. So the first 16 bits belong to the network ID. The remaining 32 minus 16 will belong to the host ID. And just to be clear, now we are not really limited to the fixed 8, 16, 24 bits for classes A, B, and C that we have seen earlier, but rather any number of bits which can be inferred as the network ID starting from the beginning on the left, and the remaining bits would be interpreted as the host ID. So let's look at an example in the CIDR scheme. All right. So we are given a host IP address 172.155.82.220 followed by a /18, right? So the first thing that we do always, we convert the decimal into equivalent binary. We don't really need to convert the /18, but only the part of the IP address. So once we are done with this, the first thing that we now know is that this is a /18 IP address, which means that the first 18 bits from the left will be a part of the network ID, and the remaining 32 minus 18 is equals to 14. So 14 bits will now belong to the host ID. So we are now breaking the whole thing into binary bits, counting them as a continuous number from the left, but when we are representing it in for IP addresses, we are using still the format of octets. So for calculating the network address, we set all the host bits to zeros. So that would mean the last 14 bits are set to zeros, and we will calculate each of these 8 bits separately to calculate the network address, right? Which comes down to 172.155.64.0. For calculating the broadcast address, we have already seen that we just need to set the host bits all to ones. So what we do is set all ones to the host ID part, which is the last 14 bits, and we calculate the decimal value of each of these octets. All right, and this comes down to 172.155.127.255. All right, and next, for calculating the network mask, we set all the network bits to ones and all the host bits to zeros. And if we convert each of these as individual octets, it converts to 255.255.192.0 as the network mask. So let's look at another example here. So first, we are given, again, a host IP address here. This one is 201.142.8.12 as the IP address, and the CIDR notation is /28, which means that 28 bits belong to the network ID, and the remaining 4 bits are only usable for the host ID part. So the first thing that we need to do is convert the host IP address into the equivalent binary, right? So once we are done with that, we can pretty easily calculate the subnet mask by setting the first 28 bits to ones and the remaining 4 bits to zeros. Next, for the network address, we set all the bits in the host ID part to zeros, so which are the last 4 bits, so we set it to zeros, and we calculate the whole IP address individually as octets, and it translates to 201.142.8.0/28. And next, for the broadcast address, we set the last 4 bits in the host ID part to ones, and if we calculate the whole thing, it converts to 201.142.8.15. All right. So now we will look at a bit more of the calculations and some more information that we can extract from an IP address. So what we're looking at are basically the first and last usable addresses for hosts that we can use for a given network. So we are given the host IP address 201.142.8.12/28, which means that the first 28 bits belong to the network address, the network ID, and the remaining 4 bits belong to the host ID, right? So we take first the host address and we convert it equivalent to its equivalent binary. Once we are done with that, we calculate the subnet mask, where the first 28 bits would be set to ones and the remaining 4 bits would be set to zeros. And we have already seen a way that we can calculate the network address by performing a bitwise AND operation of the host address and the subnet mask, or in another way by setting zeros to the host ID part and leaving all the rest intact. So this would mean that if we convert the equivalent decimal for all of these bits together, the network address comes to be 201.142.8.0. So now we would like to also calculate the first host IP address that we can use. And this basically means is the first number that you can generate that is right after the network address. So given the 4 bits in the host ID part, we set 1 to the last bit from the right. So once we set this, we again convert the whole number, and that would be our first usable IP address for any host. If you're trying to calculate the last host IP address that we can use for any host that is in that network, we now need to set all the bits in the host ID part to ones except for the last bit. The reason is because if we set the last bit to 1, that would actually make it our broadcast address, right? So the last bit, we just leave it as 0 and we convert the whole binary in dotted decimal notation. That would give us our last usable host IP address, which is 201.142.8.14. And then finally, the last bit, if we set to 1, that is actually our broadcast address. All right, so we will look at a few special IP addresses that we have as standards. And they are reserved, or by convention they are considered to be special IP addresses. The first one is what we call a loopback address, and this is in the form 127.001 till 127.00255, and they are reserved for loopback addresses. And a loopback address is basically the address that you use to refer your own interface. So if I'm trying to send a message to myself, I can use a loopback interface address, most commonly is 127.0.0.1, and this would send the message right back into my network interface. So we have IP addresses of a network as another special IP address, which we've already seen, where the host part is set to all zeros. Then we have the broadcast address, where the host part is set to all ones. And this implies if I send a message to this IP address, that is the broadcast address, it will be sent out to all the hosts in that network. And finally, we have the classes, D and E addresses, which are for test and experimental cases, which have certain ranges, which generally we don't use whenever we are trying to set up a network. And then there's another thing, which is more of a convention, that is the default gateway. So the default gateway is set generally to the first IP address of the network. So remember how we calculated the first and last IP address of any network? So that way, the first IP address, we assign it to the default gateway, which means that this is the point through which all hosts in a network will communicate through to the outside world. So let's say if we have a network which has a router which looks like this, and we have many different hosts connected to the router, and the router connects to the internet. So in this case, whenever any host would like to send a packet to the outside world, which is on the internet, it would need to go through the interfacing router. And this is what we call as the default gateway. And generally, this is an interface where we assign the first IP address of a given network, and that is the default gateway.